Civil engineering and architecture students, this is Mr. Voigt again. We're here to do, I hope, the last installment to a series of videos to find the materials estimation for our utility shed. So what we have left here is the roof, okay, and the different elements of that roof. So the first thing is we have a gable roof. Again, you should all know what a gable roof is. We've covered that. And on that roof, because it's a gable roof, we have two sides. So we have to figure out how many rafters it's going to take to build this roof with a ridge board, how much sheathing is going to go on top of that, how much roofing felt to put on top of that sheathing, drip edge to go around the edges of the roof, and then shingles to go over the top of everything. So first thing, as you can see here, we have a ridge board. Our roof is 18 feet long. Remember, our shed is 16 feet long, and we have a 1 foot overhang all the way around. I tell you right here, it's a 9/12 pitch that is on the shed that is 12 feet wide with a 1 foot overhang. But the 1 foot overhang goes on the ends as well as over the sides. So we have an 18-foot long ridge line here. The ridge line, I tell you right here, is going to be a 2x8, and obviously it's one board. So we have our ridge is a 2x8 at 18 feet. We will type that into our spreadsheet later. No figuring really needed here. Okay, so the rafters, just like when we did our walls and we did studs, we figured these out the same way. Now what this stuff is here, because, and I'm going to use this little figure right here as an example, because we don't know, well, we know the width of our building. It's 12 feet from one wall of our building to the other wall of our building. And then we have a 1 foot overhang on each side. So we have a 14-foot span here, right? So if we took half of that, our ridge board should sit right in half at the middle. We should be 7 feet. But our rafter is going to be more than 7 feet long, because if we come this way, it's going to be 7 feet to the middle. But our rafter is going to be longer than that going this direction because it's at an angle. You guys all know that those are longer than the straight. So we needed to figure out, we went online and figured out, we used there's calculators that can help you calculate the length of rafters if you type certain things in there. I went to this website and we figured out that our rafter length is going to be 8 feet 8 inches, 8 1/16 inches long. Okay, so we know each rafter is going to be that length. So we can't buy an 8-foot rafter. We have to buy a 10-foot rafter. And they come 8, 10, 12, right? Because we need a rafter that long. So if we want to know how many to buy, we got to take our length, convert it to inches. That's what we do here, just like we did with our wall, divide by 16. Okay, or we can just take our 18 and divide it by 16 inches converted to feet, which would be 1.33, right? I like working in inches. You get 13.5 rafters. So actually spaces, 13 and a half spaces. Well, you got to round that up to 14, and then you got to add one. If you remember, if you don't remember why we got to do this, go back to the wall video, and I explain it in a little bit more detail. So that means I need 15 rafters for this one side, including the very end rafters here, right? That's all of them. So we need 30 rafters total. So we need 30 10-foot. I think it's 2x6 that we use for our roof. Okay, I don't know if I wrote that on here anywhere. I don't think so, but it's a 2x6 that we're using for our roof rafters, I believe. But we need 30 of them. Okay, so that's how you figure that out. Just like, and again, this is almost identical to the wall studs that we did. The only difference is we don't have to add in for openings. At least we didn't on this roof. There is no opening on our roof, so we don't have to add in for those. Now, if we had skylights up here, we would have to add extra rafters because you have to double them up on those sides, on each side of those skylight openings. But since we don't have that, we don't have to add those in. Okay, so sheathing. On this one, just like on our sidewalls, I drew out a diagram, but again, you could have done this by the square footage method if you really wanted to. And I've done the square footage method. It does work out. So if we have 8 feet 8 inches, this is our rafter coming up. We know it's 8 feet 8 inches. We know that each end of our OSB or plywood is 4 feet. So you come 8 feet to here and another 8 inches, right? And we know we're 18 feet that way. So we go 8, 8, 2. Okay, so we can get 4 of these 2 by 4 pieces out of a sheet of plywood. So we get one there, one on the other side. So we'll have 1, 2, 3, 4 and a half. That's what this is. And then I figured this, because it's 8 inches by 8 feet, 8 inches by 8 feet, that would only be 16 inches by 8 feet. And if I add another 8 inches, I'll be at 24 to get this extra 2 feet. So this is less than a half piece of plywood or OSB, but I just count it as a half. So 4.5 times 2, which gives us me both sides, and 1/2 times 2, which gives me 1. So I need 9 total sheets of OSB. If I did this square footage wise, I would take 8 feet 8 inches. Well, 8 inches is, let me think, that's 1/3 or 2/3, I'm sorry, of a foot. So it'd be 8.66 times 18, and I can go ahead and do this. 8.66 times 18 equals 155.88 square feet times 2 sides. So that's my total number of square feet. And each sheet of OSB is going to be 32 square feet. So divide that by 32. And I get 9. Ooh, this is 9.74. Did I do something wrong? Let me look here. I get 1, 2, 3, 4 and a half. And this looks like it'd be a half. So I would need 5. Oh, I did. This 4.5 times 2 is not 8, it's 9. I'm not very smart sometimes. And remember, I told you, so I had it right, I just did some simple math wrong. I told you this is not quite a half a sheet, and I'll have on the other side at the top another not quite half a sheet. That's why it's 0.7425. You add this length up and the length on the other side up, and it's going to be the 0.7425, because I'm going to have 1, 2, 3, 4, and that's a half. The other side's going to have 4.5. So we're going to have a complete 9. And there we are. So you got to round up to 10. Okay. Good thing I'm going through this and checking. So right here, this is what I just did square footage wise, right? I took 18 times 8.66. If you look here, this is what I did right here on my calculator. Got this. And then I multiplied it by 2. It's 311.76 square feet for both sides of this roof. If one roll of 30-pound felt paper covers 216 square feet, you know we need 2. We're not going to get by with 1, but 2 will do it. You know 216 plus 216 is far more than 311. So I put 2 rolls. Pretty straightforward. Okay. Okay. Over here, insulation. So insulation is just going over the ceiling. So even though our roof goes like this, okay, our insulation doesn't go on this. We're going to have a ceiling that comes across like that. Our insulation will literally lay across the top of that. So what we have to do is figure out the square footage of the ceiling on the top of this shed. That's pretty simple. Our shed is 16 feet long by 12 feet wide. And so we just multiply those together and we get 192 square feet. So we got to get enough insulation at what we call R13, a thicker insulation, to cover that amount of square footage. So if one roll of R30 insulation is 15 inches wide by 22 feet long, then you take your 15 inches is 1.25 feet times 22 feet, and you get each one of those rolls will cover 27.5 square feet. So divide my 192 by 27.5, and I get 6.98 rolls is what it will take to insulate the top of my ceiling. So that's 7 rolls. I hope that makes sense. So while I have it under roofing here, this is actually a ceiling calculation. Okay. Last two things here. Fascia board. So fascia is a little thing. So if I draw my rafters up here a little bit better, so those are my rafters. You have to come back after you put your rafters on and put a trim board to make it look better over the top of around the whole roof. That's called fascia. So on my gable end, my rafters were 8 feet 8 and 1/16 inches long. So I need a fascia board that's at least that long and a fascia board that's at least this long on both gable ends. And then if you look back at your roof, I need one that goes the length of each long end. So that's 18 feet. So I'm going to get a 10-footer here, a 10-footer here, a 10-footer here, and a 10-footer here. And I'm going to go 10 feet this way. I'm going to go 10 feet this way. So I'm going to have 6, 1, 2, 3, 4, 5, 6. Then I'm going to come back with an 8-foot board and an 8-foot board. And that should get me around with my fascia. So what I did over here, I said gable ends 18 feet 8 and 1/16 inch times 4 equals 4 10-foot boards. The 18-foot ends equals 2 10-foot boards and 2 8-foot boards. 1 10-foot on each side, 1 8-foot on each side. So if I add these up, I'm going to have 6 10-foot boards and 2 8-foot boards when I put them in my spreadsheet. This is very much the same as this. The difference, well, it is the same. I can buy this is lumber, right? This is 1x6. I guess I should say this. This is 1x6 lumber. Here, these drip edge pieces, and you don't even know what drip edge, but it goes over the edge so that water will run off of your shingles and down over this edge instead of hitting your wood. And we can look at what they look like another time. But they come in 10-foot pieces, 10-foot sections. So instead of 6 10-footers and then 2 8-footers, we got to get 2 more 10-foot pieces, right? Right here. It's the same calculation. It's around the perimeter of that roof. So I got to get 8 10-foot sections, and I'll just have more left over. So 8 10-foot pieces. Okay. So I hope that all makes sense. You now have all these numbers, and what you should be doing is typing them in to your spreadsheet that I gave you. I gave you a spreadsheet that has all these prices in there, all these different things labeled, right? And you need to get the prices in there so that we can come up with an estimate on this shed cost. All right, you should have also gotten that instruction from me in class. All right, on to the next video. The next video will not have anything to do with materials estimation. It will be what we call heat loss or gain. That is a calculation we do to see how much heat we are either losing through our walls in a given building. When it's colder outside and warmer inside, that heat will go through the wall to the cold. And if it's summertime and it's hot outside, that heat will come through the walls and warm up our inside where it's cold. Heat goes to cold. That's the rule. Okay, so that'll be our next calculation. Until next time.